Hello, today we are going to have a practical lesson on the equations of motion. Let's get started. We have two equations of motion that describe the motion of two swords moving on some horizontal surface. The first equation describes the motion of the sword, and we see that the velocity is represented here with a minus sign. This indicates that it is moving against the x-axis. In the second equation, the velocity has a plus sign, indicating positive motion along the x-axis, and the question of the problem is to find the time and place of collision of these swords if they collide. How can we solve such a problem? You and I will consider two ways of solution. One way is called the analytical way. That is, we will be able to use the equations themselves to determine these parameters. That is, the place and time of the encounter. And we'll also see how it looks graphically. Let's start with the analytical method. What does the phrase "swords collided with each other" mean? At a certain moment, they are at the same location, meaning they share the same coordinates. By setting the two coordinates equal to each other, we can determine the time of collision by solving the resulting equation. Let's equate the two coordinates and look at the solution to the resulting equation. So, the equation of first motion and the equation of the second motion. In order to solve this equation, we need to move all the variables to one side and all the numerical values to the other side. Here we see that the 4 with a minus sign are transferred to the other side of the equation with a plus sign. We get a total of 7 here. And here minus 5t's are moved to the right with a plus sign, and plus 2t's makes 7, 0. T. From here we see that time will equal 1 second. In 1 second after the beginning of movement of these bodies, or after the beginning of consideration of this movement, these swords collided. That is, by this calculation we can tell at once whether they collided or not. If the time of movement would turn out with a minus sign, it would say that these swords cannot collide in this time. Therefore, the sign of time will also help you to understand whether there will be a collision or not. Now, in order to determine the coordinate of a given collision, we can put time into any of these equations. Let's say we put it in the first equation. Then the coordinate of the first body is equal to, and we multiply it by 1 second. And we get 3 minus 5. That would be minus 2 meters. So we've determined the time and place of the encounter. And now we can calculate the parameters of the collision using the graph. But in order to determine the place and time of the meeting of these swords with the help of a graph, we must of course first build these graphs. How do we graph such motions? In this particular situation, we make use of the initial equation to create a visual representation of it. We see that we have an initial coordinate of this body equal to 3 meters. So at time 0, this point will be exactly right here. Well, let's consider the second point. We can assign a time value like 2 seconds, for example. If we multiply 2 by -5, we get -10. Adding 3 to -10 gives us -7. Therefore, at the time of 2 seconds, the object is positioned at the coordinate of -7. Here we're just going to continue our graph and show its position at this point in time. So the end point of this body is here. Now we do the same thing with the second equation. We see that the initial position of the body at time 0 will be -4 meters. That is, the starting point is here. And we also substitute, let's say, the same 2 seconds here. 2 times 2 is 4. 4 minus 4 is 0. And so this point will show the second point belonging to this line. Now we can use these points to draw these graphs. And now let's see how the graphs of this movement will look like. So I remind you that these 2 points belong to the first body. So we draw a line for them. And accordingly we do the same for the second body. Here I pay attention to the fact that this point is not the end point of this graph. That is, the graph can continue further, because we do not know when this motion ended. The same is true for a given body. That is, the graphs themselves can be infinitely long. But it is clear, since we are talking about some physical phenomenon, such as the collision of two swords, before the collision they will move according to these graphs, and after the collision, in all likelihood, their motion will certainly change. Now on this graph we see that the point of intersection of these two bodies will determine a place and time of meeting of these objects. Well, taking into account of course some inaccuracy on this graph, we see that the time of motion in general we have the same, that is 1 second. And the coordinate of the body, well, approximately we can say that it will be equal to -2 meters. This method clearly shows that there are certain errors in the calculation of such problems. That is, the moment and time of meeting can be found by crossing these graphs, but they cannot always be found with great accuracy because there are certain errors in the corresponding devices. The analytical method in this respect, of course, is more accurate, but graphically allows us to visualize more clearly how these bodies behave. This concludes our practical lesson. Goodbye.